Okay, I have a video for you. Okay, they're talking in French, so okay, we'll watch that again. So, what I want you to notice is which direction does the lion's body go after it's kicked. Which way does the lion's body move after it's kicked? The right or the left? Continues to move to the left. Everybody see that? Okay. Don't feel too bad for the lion. He was trying to kill a zebra. Like the zebra is the underdog in this scenario. So if the camera angle was moving with the zebra, the line would have looked like it went backwards. Does that make sense? Okay. But in this case, the line just slowed down, but continued to move in that same direction. Does that make sense? Yep. All right. Take a shot at this. We'll be able to determine if something that sticks or something that bounces produces the greatest change in momentum. All right. Give this one a shot. Tell your neighbor what you think. Correct answer is remember direction. You could either do it this way or this way. positive 20 meters a second minus a negative 30 meters a second gives you a positive 50 times 0.5 gives you a positive 25. Here, positive is to the right. Okay. Good with that. Direction is essential. Okay. Thumbs up. I have a guess. Talk to your neighbor. Correct answer is try that again. Okay. Here's a little trick. When in doubt, make up some numbers to go with the scenario. All right, so initially, let's say they both have a momentum of 10 going downward. So you have your bing bag and you have your bouncy ball. So right before the ground, they have negative 10 kilograms per meter per second. When the beanbag hits, what's its final momentum? Like after it hits the ground. Everybody okay with that? And the ball, its final momentum is like, I don't know, up probably less than 10, say a positive 7. Which one experienced a greater change in momentum? Tell your neighbor. There we go with the ball. Okay. Ball experiences a greater change in momentum. Okay. It goes from, the beanbag went from something to nothing. And the bouncy ball went from something, if you did slow motion, something to nothing to something again, but in the opposite direction. All right with that? A greater change of momentum. Have a conversation. Tell them why you think so. Correct answer you think is? We're gonna find out. All right. Someone help me. Mouse it, guy. All right. So I've got. I'm doing that for this camera because I can't see the ball. So this is called happy ball, sad ball. You figure out which one's the sad one. Okay. So this is going to be my bouncy ball, obviously. This is going to be my clay ball, except for the fact that it needs to stick. That's a really important detail. So I'm going to take that clay ball and I'm going, or the sad ball, I'm going to wrap it with some Velcro. Okay. So it sticks. I'm going to launch it at a door. Okay. And it's going to be consistent speed because we're just going to go at the same setting. Okay. Quick disclaimer. Velcro is getting a little tired, so sometimes it doesn't stick, so we'll just redo it. Okay. Ready? 3, 2, 1. Nice. Right there. Good with that? Like, okay, can everybody see the bag? Like, is that a good marker? Okay. So now we're going to go with the bouncy ball. Ready? 3, 2, 1. Thank you. What? The bouncy ball like went twice as far. You guys see that in the camera? Twice as far. Here's the bouncy ball. No. There's this clay ball. There's the bouncy ball. Why? So, in a collision, both objects always experience the same force for the same amount of time. Good with that? Both objects will always experience the same change in momentum. Ball, regardless of what type it is, door. Okay. Which ball experienced a greater change in momentum? The bouncy ball or the clay ball? The bouncy ball. You okay with that? I mean, that's what this discussion has been leading up to. The bouncy ball, because it changes direction, experiences a greater change in momentum. Therefore, the door experiences that same greater change in momentum with the bouncy ball versus the clay ball. Okay. But you might say, doesn't the clay ball exert a force for a greater amount of time? I mean, it sticks to it. Okay. The force times time approach gets fuzzy. But here's the reality. The clay ball only exerts a force to open the door when the speed of the ball is different than the speed of the door. While it's deforming, it's exerting a force. But once the speed of this matches the speed of the door and they're just moving together, the clay ball no longer exerts a force to make that door open up. Does that make sense? Okay, there is some sticky force, some cohesion, but it's not like causing it to open the door because it's like, oh, it's sticking longer. It applies that force while it squishes, but once it stops squishing, no longer exerts a force. How are we doing with that? Okay. Tell your neighbor. Correct answer is A. Good warm-up question. Just like the skateboard and medicine ball. Talk to your neighbor. Oh, that made it worse. Oh. What did you say? Okay, so this question is getting at after it sticks. Everything stops. The frame by frame would look like this. Here's the ball, here's the guy in the cart. But once this hits, it stops. Good with that? Correct answer is C. Okay. after the 6th. To the last one. Tell your neighbor. Correct answer is B. Okay. Overall picture, total momentum of the system is 0 initially. Afterwards, it still needs to be 0. You got something moving to the right, therefore something needs to be moving to the left to cancel that out. The frame by frame would look like this. Guy, cart, ball. Does that make sense? Talk to your neighbor. Correct answer is C. What's the total momentum of this system? Of the two cars? 0. So when they hit, they stop. Just like this, when it hits, it stops. Okay with that? Last question. Tell your neighbor. Correct answer is C. Internal forces. You all right with that? Okay. That's the game today. I'll post a review worksheet